Very good. What will be the first step before we touch the equation? What is the first thing that we said we should do? Unless you commit to check at the end. But if you like to use my method, what will you write first, immediately and quickly? Let's not waste time, please, help.
Is it restrictions?
Yes, yes, please say 2x plus 1 greater than 0 and x minus 2 greater than 0. These are absolutely necessary. If you use the method that I like, if you don't want to state a domain, then you have to make sure that you check at the end. Good. So this is x greater than negative 1/2, and this is x greater than 2. But we need the common territory. So we have greater than negative 1/2, and we have greater than 2. What do I pick? Oh, this is not good. What do I pick? If there is a solution, where will the solution be? For sure, if there is one.
Greater than 0? Greater than 2?
Exactly. So if we don't find a solution greater than 2, we should say don't even bother. It's not going to work. Good. Next step. I will move this log to the other side. So I have log of 2x plus 1 minus log of x minus 2 equals 1. Can anyone refresh our memory on how to condense the left-hand side? How do we condense a difference of logs in the same base or with the same base? How do we condense the difference, please? Help.
You divide what's in the parentheses?
Yes. So we have log. Thank you so much for saving us again. Good. Now, what is the equivalency? Log equation is equivalent to an exponential equation. Which exponential equation replaces this? Okay, here's a hint for you.
Is it 10 to the power of 1?
Exactly. So 2x plus 1 over x minus 2 equals 10. Very good. Excellent. What type of equation? We just had one 10 minutes ago. What type of equation is this? What do I do? Anyone, please? We want to work on other problems and review other problems. Anyone, please?
Proportion?
Yes. Yes, proportion. So I'm going to cross multiply. So 2x plus 1 equals 10x minus 2. Excellent, because this is over 1. Great job. Proportion, only in a proportion we cross multiply. Now this is linear. So I have 2x plus 1 equals 10x minus 20. I move terms around. I bring this here. I get negative 8x. I bring this here. I get negative 21. So finally the answer is and you don't have to divide, you can leave it as is. What is it?
Isn't that be a positive 21? Because negative 20, and then you would add 20 to 1.
So maybe you see something and I don't. Let me just so you're saying that this is okay. This step is okay.
Never mind, I see what you did.
No. Maybe you're right. Maybe I'm wrong. Are you sure?
Yeah.
So is this step okay?
Yeah, that's fine.
Okay.
The next one, you take.
So I took 10 to the other side and I changed its sign. And I took 1 to the other side and I changed its sign.
I did it the opposite.
That's fine. We still have to get the same answer. It doesn't matter. So we still have to get 21 over 8. Is 21 over 8 a number greater than 2? If it is greater than 2, we'll accept it. If it's not greater than 2, we'll say no way. Accepted or not?
It is.
Thank you so much. Great job. Very good. Next topic. Sorry, I should have asked. Any questions? Okay.
I do have one.
Yes, please.
So you did a subtraction of logs, right? What if you had an addition?
Addition. If it were an addition, I would have multiplied these two side by side,
Okay.
not divided them. But because we are subtracting, we have to divide.
All right.
Thank
Thank
you.
you.
Thank you. Good. Other questions? Other topics? Are we okay with graphing? Are we okay with difference quotient?
Are we finished with all the units for the test right now?
Correct.
Oh, can we do more of the, what is it, synthetic division?
Sure.
Because I was gone for...
Yes, of course. Very simple. Yep, here it is. So 3x cubed minus 2x plus 1 divided by x plus 1. Is synthetic division applicable? Yes, because the denominator is x minus a number. So what goes in the box?
-1.
Excellent. Now careful, the numerator has to be in descending order. If there are missing terms, we have to write 0. So because the degree is 3, I have 3, then the degree 2 is missing. Degree 1, it has coefficient -2. Degree 0 has 1. We always, first step, we move 3 down. -3 times 3, I'm sorry, -1 times 3 is -3. We perform the operations we see. 0 minus 3 is -3. -1 times -3 is 3, and we write it above the line. Perform the operations, we get 1. -1 times 1 is -1. Look at that. Wonderful. So then, I need the quotient plus remainder over the divisor. Since the remainder is 0, this will go away. So what is the final answer? Can anyone identify the final answer for us? Remember, we are dividing degree 3 by degree 1.
3x squared minus 3x.
Brilliant. Thank you, Blake. Awesome. Well done. Indeed. 3x squared minus 3x and plus 1. That's it. There is nothing. How will I determine the remainder? I have this divided by x plus 1. What if I don't want to find the quotient and the problem is asking me to find just the remainder? How will I do it?
Sub -1 in.
Exactly. And because the remainder is 0, what will you say about x plus 1? Is or is not of 3x cubed minus 2x plus 1?
When it is a factor.
Very good. Thank you, Blake. Thank you. Is indeed a factor of 3, not OP, but sorry, 3x cubed minus 2x plus 1. That's why I have my whiteout. What will I do without it? Excellent. Well done. Tim, is this okay?
Yes, so then with the remainder theorem and like factor theorem, that's just plugging in. That's like when you put
When
negative
yes, so if
x
you're
or x?
if you're only asked to find the remainder, all you do is you plug in here -1, and you
Oh,
just
okay.
get the remainder. Now, because the remainder is 0, then x plus 1 must be a factor of the numerator, because the remainder is 0.
Okay.
Perfect. Excellent. Other topics? Difference quotient. We need to review the difference quotient. Is that a yes? Is that a no?
Could you do another factor and remainder theorem example?
Yeah. So this was exactly the same thing. This was it. This is in addition to the synthetic division. So if I'm asked to find the remainder of this division, just plug in -1. 3 times -1 cubed minus 2 times -1 plus 1, you will get 0. So the remainder is the polynomial evaluated at -1, and we get 0. That's the remainder theorem. And because the remainder is 0, then x plus 1 is a factor of 3x cubed minus 2x plus 1. That's it. Is that okay?
Yes.
Is it good enough?
It's fine, yeah. Okay, I just didn't really, I don't know how to explain it. It just kind of,
So if I have, for example, this division, let's say I have 4x to the 4th minus 3x plus 2 divided by x minus 2. The remainder of this division, so I'm going to call the top polynomial p of x, the remainder will be p of 2, whatever it is. 4 times 16 minus 3 times 2 plus 2. So 64 minus 6 plus 2 is minus 4, so it's 60. So the remainder theorem says that the remainder of this division is obtained by replacing x by 2. Oh, of course not there. Because this is not 0, x minus 2 is not a factor of p of x. That's all there is to these two theorems.
okay, thank you.
Now, if the denominator is x squared plus 4, you cannot use these two theorems. The denominator has to be x plus 5 or x minus 3 or x minus 2 or x plus 1. It has to be a linear factor. Good? Anything else? Are we okay with the difference quotient? One more time. Do we need to review that?
Could you go back to that last page?
Yes, of course.
With rational zero theorem, how do you know which of the combination to use?
You have to test. You have to test them all.
All of them?
Absolutely all of them. So when we looked at that problem, we had the function here, and then we went to second and table, and we plugged in +1, -1, +2, -2, +4, -4, +5, -5, +10, till you find the number of the solutions that you need. You have
How
to
would
test.
the solution look?
How will the solution look?
Are they going to be points on the graph?
Yeah, these are x-intercepts.
Oh, okay, okay, that makes sense.
Yeah, these are the x-intercepts or the solutions. So we plugged in plus minus 1, plus or minus 2, plus or minus 4, plus or minus 5, and so on and so forth. We plugged all these in, and We didn't have to plug in the last 4 because we already found 4 solutions, because 3 solutions because the degree was 3. I was not going to continue with the other 2. I can't find more solutions than the degree. And then we stopped.
If we had like one of those questions on a test, would you want us to show the work of plugging the x's back into the function?
No.
Or would you just be okay
No.
with the calculator?
No, exactly how I wrote it here. You write the list,
Are you good
and
with the
you just said, I
calculator?
found these 3, good enough.
Okay.
No, I don't want you to write anything else. Good.
Can we go as quotient?
Yes. Very good, thank you. So let's look on a difference quotient. Here it is. Let's say f of x equals 2x minus 1 over x plus 3. You have to remember that the difference quotient is, since you can use your notes, please have this handy at all times. Please write 2x plus 2h minus 1 over x plus h plus 3 minus 2x minus 1 over x plus 3, everything divided by h. Please write the least common denominator, which is always the product of these two, and then you will eventually multiply by the denominator. Please remember to make the necessary adjustments. So this needs an x plus 3, and this one needs an x plus h plus 3. Please remember 2 items, 2 notes. Number 1, when I put whatever I put here, all terms without h must go away. Some others may go away, but I don't hold my breath. But definitely those without h must go, and then eventually this h must go. So these are crucial steps. If it doesn't work, something is wrong. So careful how you distribute. We distribute x. 2x squared plus 2xh minus x plus 6x plus 6h minus 3. Watch me right out of room. I always do. Negative 2x times x. Negative 2x times h. Negative 2x times 3. Negative times negative 1 is positive 1. So plus x plus h plus 3. Now, if my terms don't go away, I know I have a big mistake. The negative 2x squared with a positive, look at this, even these two are going away. Wonderful. The negative 6x with a positive 6x. The positive 3 with a negative 3. The positive x with a negative x. So all is left is this and this. Nothing else. I'm happy because now I only have a 6h plus an h, 7h. Okay? So this is 7h divided by the whole thing. X plus 3, x plus h plus 3. I finally simplify. And I'm done. This should not take long. If you know what you're doing and if you practice these examples that we had in class, it should take you 3 minutes at the most. Now, if you have to start looking for your mistake, it may take you 15 minutes. Any questions on this? The more you practice, the better you get at this. And this is a crucial topic for Calc 1. Very important. If you know this in Calc 1, you have 10% of the course under your belt already. I'm not kidding.
Sorry.
Go ahead.
Did you say that the exam was open notes?
Yes.
Right?
Correct.
Okay.
If you go in with more than 2 pages, I would like to say that you haven't studied enough. If you go in with 500 pages, I doubt that you can finish. Please do not go in with 500 pages so you can start flipping through pages and look for something, because you're not going to finish the test. summarize the notes, go through all the notes from all classes so far, everything. So you are prepared. You've seen it all in class. There is nothing that we haven't covered in class, I promise you. Good. Let's continue. Anything else?